and welcome to podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who has donated to the show. Your contributions help us make the show sustainable. Linode is sponsoring us this week. Check them out at linode.com/podcastinit and get a $20 credit to try out their fast and reliable Linux virtual servers for your next project. We are also sponsored by Sentry this week. Stop hoping your users will report bugs. Sentry's real-time tracking gives you insight into production deployments and information to reproduce and fix crashes. Check them out at getsentry.com and use the code podcastinit at signup to get a $50 credit on your account. To help other people find the show, you can leave a review on iTunes or Google Play Music and tell your friends and coworkers. And you can also join our community at discourse.pythonpodcast.com for your opportunity to find out about upcoming guests, suggest questions, and propose show ideas. Your hosts as usual are Tobias Macy and Chris Patty, and today we're interviewing Steve Dower about Python on Windows. So Steve, could you please introduce yourself?
Yeah, hi, my name's Steve. As you can probably tell straight away, I'm Australian. I've moved to the US about 4 or 5 years ago now to start work at Microsoft. So I've been working there for that time on a lot of the Python tooling and Python libraries and stuff that you will have seen coming out of Microsoft recently. And in that time, I also got involved directly working on CPython. So I've been a core contributor for a couple of years there, maintaining and just really trying to support the Windows platform.
So how did you get introduced to Python?
It was initially a summer vacation job that I had in between studies. So I had a few months off and had a friend set me up with a job, which he knew about. And this job was designing medical devices. They're actually a startup. They're in early stages of setting up demonstrable prototypes of their... what were they doing? They had these little cards that were sort of going to be pre-filled with all the medical testing stuff you needed, and you would be able to inject a sample into this card, stick it in the device, and it would pump everything around, and eventually one part of it would change color, and we could detect the color change and give you the results. So the idea was that you could send, an HIV test. You could send 1,000 cards, each of which is an individual HIV test, and someone who's not a medical professional could do it. So I was working there for a couple of months. They were building a prototype system which was being automated with Python. So I had to learn Python at that point. This is about 7 years ago now. I learned Python to automate this system and build that. And from there went straight into a PhD, and on the first day my advisor comes to me and says, "Hey, I have all of this code that you can use, but it's in Python." And I just went, "Oh, great, I know that now, so let's go."
So you're currently the release manager for Python on Windows. How did you end up with that responsibility?
Basically, I volunteered, and everyone said, "Hooray, we have someone who wants to work on Windows." So that came out of going to PyCon, which, so all my work at Microsoft has been around Python. We've been able to go to PyCon for a number of years and sponsor the conference and have a booth there and just get to meet a lot of people. A couple of years back, there was a lot of discussion going on about packaging, and I went to one of the panels on that. And at that panel, Nick Coughlin, who's very heavily involved in the packaging side of things for Python, basically called for more help, called for more people to come join the distutils SIG mailing list, and just be available to discuss and figure out some of the problems that we were facing at that time. So I volunteered for that and said, I'm familiar with Windows. It sounds like I'm more familiar than a lot of the people who are in the room at the moment. I'm happy to come and help out. Fast forward a year to the next PyCon. I'd been doing that. And essentially I did the same thing and said, "I've noticed the installer has a few issues. Is anyone going to mind if I come in and submit a few patches or, update it a bit?" And everyone was sort of like, yeah, sure, go ahead. Talk to the guy who's currently maintaining it. The next day, the guy who was currently maintaining it sends an email saying, "I think I'm done. If you can find someone to take over for good, that would be great because it's time for me to step away." And so I stuck my hand up again and got the job. And since then, I have rewritten the installer completely. I've rewritten the build completely on Windows and gone back and fixed some of the older, more obscure bugs that have just not been fixed in that time.
Yeah, I know that for quite a while, the overall experience of getting Python installed on Windows and being able to set up your path and environment was rather difficult and fraught with peril for certain use cases. And from what you're saying, doing the complete rewrite of the installer has greatly improved that experience. I know that I recently installed Windows on a laptop for my son to start teaching him Python, and it was much easier to do that recently than it was when I first started trying to use Python on Windows about 6 years ago. So I'm wondering if you can give a bit of background on some of the improvements that you made there and some of the issues that you came across in the process.
Yeah, so one of the big differences between, I guess, the Linux world and the Windows world is there's a really big cultural difference between hacking software, I guess. So on Linux, basically all software, there's a few sort of device driver exceptions, but essentially all software comes down as source code, which you'll then build on your own machine and have a result that fits perfectly. Windows, the culture has always been you download the binaries, or you get a CD or even a floppy disk at one point with the binaries on, and you can just run them. And maybe there's an installer, but all that's really doing is copying them onto the disk. There's no compilation step taking place. Because of that, developer tools almost always come with a compiler, but not everyone gets a developer tool. So one of the big issues that Windows has been facing for a long time is when you get Python, you aren't actually getting things like a C++ compiler or a C compiler even. And as a result, when you then need one, because you're in the developer tools world now, you need a C compiler, you don't have it. And so a huge majority, I would estimate, of people with Python on their machine don't have a C compiler, and you just have this disjoint culture. So the Linux package developers are saying, I can publish source code. When people install the source code, it will compile and they'll be good to go. And that's really baked into Python through distutils library, and setup tools are just have been assuming that for so long that installing packages, well, of course you'll have a C compiler because everyone has a C compiler. And just Windows has not had that. So people will often hit packages that can't be installed because they're missing a compiler. There's a number of other things. The sort of culture of living at the terminal, living at the console is not the same on Windows. It's a point and click environment and has been for, I guess, 20 years now, more than 20 years. You work with a mouse. Occasionally, like keyboard is for input into a program, not for starting the program itself. So things like environment variables, things like the current working directory don't have as much of an importance on Windows as they do on other platforms. And as a result, things like Python that heavily rely on those global settings don't necessarily behave the same way and don't work as well or as smoothly or cleanly as they do on a platform where environment variables are front and center. Everyone uses them all the time. Everyone knows how to set them and knows how to adjust things like the path, which on Windows doesn't make such a big deal. So as for fixing that, honestly, I haven't really done much to fix that. The biggest change the installer has made recently, so since 3.5 when I rewrote it, is being able to do a proper installation for a user who is not an administrator on their machine. Because previously that was completely impossible. You had to be an administrator, you had to be able to change system level files to install Python on your machine, and this was excluding a lot of students who had machines issued by their schools. A lot of research departments were given computers by their schools and not given permissions in a lot of cases. That was my situation until I replaced the machine my university gave me with my own one. A lot of businesses cannot install, won't let their employees install things on their own machines because that's, I get it's the policy, it's the culture around it, and it's how it's used. So being able to make the Python installer still install in those situations and give someone a working copy of Python is, I think, the biggest change that I've made so far for 3.5. And frankly, it makes a lot of terminal usage harder to do it that way. It doesn't really make it more like Linux. It's making the Python installation more like a Windows program should be. And I've also made a few sort of more technical changes within the core for software that wants to embed Python, which is a fairly common thing. There's a lot of software out there on Windows that You install it through a normal installer, and in the background, it's running Python. It's got the Python DLL, it's loading code and running it, and there's just a few changes in 3.5 that should make that easier for the developers who want to do that and distribute Python as a library of their application on Windows.
Just being able to install Python to a user's account rather than requiring the admin privileges, like you said, greatly increases the overall reach and availability of Python for people in a large number of situations. And also, maybe kids who have parents who are savvy enough to be able to lock down the machine and not give them complete admin control over everything. So it definitely broadens the range of people who can now potentially start experimenting with Python, whereas previously it just would have been out of the question.
And just to add to that, since the Python installer was last majorly updated like this, Windows changed the model so that by default you're not an administrator. So you don't even have to be that savvy these days to lock down your child's account on a Windows machine. By default, it's locked down. And that is just such a change. Like it's a big change in culture. It upset a lot of people when it happened because it changed everything. But that is fundamentally new since the installer was last done, and so it needed to be resolved.
And going back to what you were saying earlier, too, about the fact that most Windows machines don't have a C compiler available for being able to install packages with C extensions, some of the recent updates to how those packages are distributed, namely Wheels, has made that a lot easier as well. I don't know if you can speak to that a bit.
Yeah, so Wheels were just coming about they were, I guess, gaining acceptance at that point where I started joining in on DistriTil SIG. They've been under development for a long time, a lot of people trying to solve this problem. And it's not just a Windows problem even. It's a lot of places, a lot of people want to build once on Linux and keep reusing the build because they know they have a compatible machine. And so they can use Wheels, and they do use Wheels to set up maybe an internal package server, and then maybe on 1,000 machines, instead of installing and compiling a package over and over again, they'll pull down that wheel, which is essentially just a zip file with all the pre-built packages inside it. They'll pull that down and install it, still using the same pip install command, and it's a lot quicker than running it through the compiler would be. So it's been a problem that's being worked on for a long time, but it's hit a point now where I don't have numbers handy. I'm sure someone does or can get them, but so many packages on the Python package index are coming with Wheels now, at least for Windows. There's the option now to put up highly compatible Linux packages that will work on most distributions that are out there, and certainly packages for Mac can be put up there, which just means that installing packages doesn't require a compiler in so many cases now that you can almost forget that you don't have one. Simultaneously, one of the great things about working at Microsoft is I get to go and chat to the people who manage things like the compilers, and so I can go and sit in their offices and chat with them about here's why we should make it easier for people to get access to the compilers. So in the same time that that's been going on, I've organized putting out a copy of the old compiler that people need for Python 2.7, and so that's available from a link which we'll get in the show notes. And I've also been able to help encourage the compiler team to put out a much simpler bundle of the most recent compiler, which is called the Visual C++ Build Tools 2015, I believe. Again, I'll give you a link for the show notes, which is not a full Visual Studio install. It's not the same licensing things. We want people to have the C++ compilers because that means they're building things for Windows. That's good for the ecosystem. So we want to make the compilers easy to get, and we've been able to improve that. So now it's actually not that hard to get the compilers you need to build packages on Windows, but with so many developers having or publishing Wheels for their packages, it's less necessary.
What an incredible paradigm shift that is. Just want to sort of take a moment to appreciate that. I mean, for so long, those of us who've been around in the industry for a while remember that, you know, vendors were so incredibly guarded about releasing compiler technology of any kind, and this idea that end users should be empowered to build their own binaries was almost heretical, you know. So it's it's a really wonderful change that's been happening, especially at Microsoft and other vendors too. But it's most heartening to see happening there, because Microsoft used to be kind of one of the seats of binary culture, right?
Yeah, oh, absolutely, absolutely, and I would say that it still is. I mean, it's certainly not moved to the point where regular end users are expected to be able to compile stuff on their machine. Again, it's very easy to have a small view of who your end users are. The range of people that are capable of getting a machine running Windows versus one getting a machine running even Ubuntu, but some of the more obscure Linux distros that are just a little harder to get set up and running and keep running. There's a huge base of Windows users who cannot and should not be compiling anything at all. They should not have the C compiler on their machine because they need those few gigabytes of space for photos, for videos, for music, and they're simply not interested in building things. So while there is a shift for the enthusiasts and I'll call them the amateur developers, but it's anyone who wants to build things for the platform without having the backing of a large company behind them. Things like Visual Studio Community Edition are specifically for supporting those, and you can see that from the license. It's a full copy of Visual Studio, the same thing we charge thousands of dollars for to companies. But if you're not a big company, or if you're working on open source software, you can have it for free. There's no restrictions. It is simply the case that there are now there's a big movement of amateur developers out there who are not a company making millions of dollars every year off their software, and we want to encourage and support them as well.
And given that a large percentage of overall computer users are still on Windows, having a good story for them to be able to get started with Python is definitely important. And we mentioned a few improvements that have already been made. Wondering what are some of the areas where the current situation still needs to be improved? And are there any areas that would be ripe for listeners of the show to potentially contribute?
So I am still one of the things that I am sort of constantly working on in the background as part of my day job is speaking to the people we need to speak to about how do we make, opening a command prompt on a brand new install of Windows and typing Python do something useful. Because right now that gives you an error message. It's the only operating system in popular use, even unpopular use, that's going to do that. Just give you a flat out error for, you type Python, that's not a real thing. So I'm certainly working on trying to come up with a better approach to that, a better response to that. But as far as other things that Python needs on Windows right now, migrate to Python 3.5, please. It's a considerably better experience on Windows now than 2.7 is, and even 3.3, 3.4. So 3.5 is going to be much better. 3.6 hopefully will be better again. And the other thing is encourage package developers to produce wheels. And if that means you have a Windows machine and you go to them and say, I am happy to build the wheel for you on my machine, I'll run the tests and give it to you so you can publish it. If that is simply being there to test and give that response. And again, it's the enthusiast developers who have a C compiler on their machine who can do this and start contributing to a package just to get a wheel up there so that all the other developers who are simply using Python and want to be able to use that package are able to install it and just use it.
Yeah, having build hardware for platforms that the developers aren't generally working on is usually a bit of a pain point for making a package generally available to other platforms. So I know that, for instance, the Kivy folks have had some issues occasionally with getting builds available for OS X and for Windows because most of them are developing on Linux, for instance. So I don't know if that's an area for people to potentially contribute, having Windows build servers, or I know that with the advent of cloud computing, that's sometimes easier to do where they can just rent a Windows instance for a little while to build their packages and then distribute them.
Yeah, that's certainly a good option that plenty of people are taking these days. There's a lot of work to be done there just as far as making that simpler for people to do, which is, again, also something that is kind of constantly buzzing around in my head. How can we make this really easy for people who don't use Windows regularly, who aren't familiar with it, but need to be able to build something, need to be able to diagnose when the build fails, why the build fails, do that testing, do that analysis, which again, if you jump into a native debugger on Windows, you're going to see very different things than a native debugger on Linux. And how do we make that entire workflow easy enough that we can legitimately start going to these projects and say, plug into this and you'll get your Windows build, and here's how to deal with things that don't work.
Another question that comes up is you're saying how the way that Python is installed on Windows and referenced is a little bit different than how it's set up in Linux, in terms of path and environment variables. And I'm wondering if that poses any difficulties for people who are trying to build cross-platform projects.
My hope is that it would not. So it's largely, and this is a great opportunity for me to talk about my first PEP, which was ever accepted. I recently had PEP 514. Was approved and is now an active PEP, which is about configuring the registry on Windows for locating Python installs. So one of the things that we discovered through some of the telemetry that Visual Studio has is that most of our users on Windows have 2 or more copies of Python installed, which is a totally legitimate thing to do. I have about 16 copies of Python installed on most of my dev machines because that's what I do. But we definitely found that the majority of our users had 2 or more. And locating each of those by simply typing Python at a command prompt is not actually useful. You're going to get one, you're going to get the other. It will be consistent on your machine. It may be different on someone else's machine who installed things the same way. There's just no reliable way of doing it, relying entirely on path. So what PEP 514 defines is the set of registry entries. So the Windows registry, for those who aren't familiar, is essentially a hierarchical configuration file. It has a global per machine section and a per user section that are independent, can be read independently. So Python has always registered itself in either the per user one if it's installed per user, or the per machine one if it's installed for everyone, which means that anyone on that machine can look in the registry and say, oh, where is Python 3.5 installed? Here it is, now I can run it. And again, because most Windows users are not going to the console and just typing Python, they'll be going through some shortcut, they'll be going through some other program. It's able to use the registry to find it and execute the right one. Where that ran into problems is if you have collisions in that, you can only have one value under a certain key. So if that key says this is Python 2.7 and you install somehow 5 different versions of Python 2.7, which is actually entirely feasible, then you get collisions, you can't find all of them. PEP 514 is designed to disambiguate that, to make it possible to have each of those identified separately. So it's a different model from what you see on Linux. I have seen PyEnv, which will do some clever path searching on Linux and give you that free choice of, I have all of these different ones installed and I want to choose which one to use right now. That doesn't fit the Windows model. The Windows model is, this is the one that I want, look it up, run it explicitly, and not change the sort of ambient state of which one I'm using right now. But that should make things no harder for package developers in theory. And with proper tooling around it can make it easier because it makes it a lot more feasible to have many copies of Python installed on the one machine and be able to accurately choose which one you want to use right now.
And back on the user side, how does that tie into things like virtualenv?
So virtualenv could potentially take advantage of that information that's there for letting users choose which Python to work from. Typically, most people are going to simply run virtualenv out of the version that they want to inherit from. But you can specify any version of Python to base it on. So you can type virtualenv, I believe it's -p, and give the full path to the Python executable you want to base it from. So it doesn't matter if it's not the same version. It will go off and run against that and give you that environment based on a different version of Python. So that could potentially make it so you don't need to know the full path of where it's installed. And given that the default install path changed recently from a very short C Python 3.5 or C Python 3.4, Python.exe, to something more like C users, my username, app data, local programs, Python 3.5, Python.exe, not having to remember that full path could be very handy. So that's the kind of thing that information can enable. And certainly when you get into GUI applications like the IDEs, Python tools for Visual Studio, PyCharm, Wingware, they can just display a graphical list of everything that's registered on your machine, and you can simply click the one that you want right now, and you'll get it.
So what is currently the most difficult part of building a distribution of Python for Windows, and has that gotten easier in recent years?
I believe it's gotten easier. I am a compulsive automator, so when I hit a problem that I have to do more than once, I will find a way to script it. So I have a collection of scripts, some floating around, some actually checked into the repository for CPython, that will do the build. So I have a script and a big bundle of files that will set up my build machines for me. And there's no magic there. It's just simply I can't redistribute an entire copy of Visual Studio. So that's my private script I can pull up a clean VM and have everything installed very quickly. But then actually building the distribution of Python for Windows it's one batch file. So it's one shell script that I can run that will do everything with only a few options. And again, I optimize them for my use cases. It will code sign all the binaries. It will run installation tests. It will do the 32-bit, the 64-bit versions of Python. And I can kick that off and walk away for an hour and come back and it's all done. And then I have one more batch file to upload the official release. Those are both checked in. And it's considerably easier now, I believe, than it used to be. But again, it's my automation. I understand it. So far, I'm aware of one other group that's made use of it and has made a few tweaks to the installer and run and is using these batch files to produce their own distribution of Python 3.5. So it has helped other people. I believe it's easier. The most difficult part is getting hold of the tools, but even that with the C++ build tools, which are sufficient for building Python. I just did it recently on a new machine. It is easier than it's ever been in the past, I believe, to get the tools you need onto a machine. I haven't tested this explicitly, but I believe all you need is a copy of Subversion and a copy of the C++ build tools, and everything else will be installed as part of the build process. So that should be all that's required to get started building Python on Windows is Subversion and the C++ build tools.
That's definitely a big improvement because I know that, at least as of a couple of years ago, being able to build the Windows distributions for Python was a bit of a black art that had a fairly low bus factor. So having it automated is definitely a good step in the right direction. When we were speaking at PyCon, you mentioned that the most frequently downloaded version of Python from the python.org site is actually the 32-bit distribution for Windows. I'm wondering if you think that that's an accurate and useful metric, and wondering if there are any other statistics that you wish you could capture or improve.
Yeah, so we don't do a great job of capturing the statistics from there. I managed to get access to the raw logs from someone there who trusts me, which is very kind of them. So I've been able to pull those down and do some basic analysis just to get an idea of what people are actually downloading. So it turns out that since I last spoke to you about that, the downloads of Python 3.5.2 are blowing away everything else. They're about double. So per average per day is roughly double what Python 2.7 is getting at the moment, or 2.7.12 is getting. So as far as people downloading the latest versions of Python, there's about 2/3 going for Python 3 versus Python 2, which is awesome to see. Really exciting to see that. There's a few odd versions of Python 2.7 that are still being downloaded. 2.7.5, for some unknown reason, is really popular. 2.7.3 is still up there as well. But the downloads of the installers for Windows are an order of magnitude higher than the next set of downloads, which is the installers for Mac and some of the source distributions available there. So there's clearly a huge interest, and we're talking something like 5,000 to 8,000 downloads a day, roughly. Again, I don't have precise stats, but that's ballpark area. There's a number of thousands of downloads a day of each distribution, so it's very popular on Windows. Most people, I believe, are coming to python.org to get it, and the breakdown within versions of Python, I think, is heavily biased by the first download button that you see on the site. So when you go to the python.org site, certainly on Windows, I assume it changes on other platforms, and hit download, it presents you with download Python 3.5, download Python 2.7, and that link takes you straight to a download. So that's obviously going to be the most popular download because it's the fewest clicks to get there. I've thought about experimenting with getting that changed to point to something else and see how things go, but really there's no point in that. Python's a 20 meg download, which is not that big these days for most people. If you click through, there are smaller downloads. There's a web installer that will let you deselect options before you've even downloaded them, which if you're not interested in Tickle, if you're not interested in the documentation, if you're not interested in the test suite, you can get it down to a 7 meg download for the entire thing. And people are using that as well, which is great to see because I put a lot of work into making that actually work. But yeah, as for other stats that I'd like to see, I can probably already get them. I just don't actually know what I should be interested in. It's not really fair to compare downloads for Windows to other platforms because other platforms have other ways of getting it. We know that, and again, Windows users are quite often going to Continuum Analytics or Enthought to download their distributions. They get a lot of Windows downloads as well, certainly more than their other platforms. But again, for Mac users, a lot of them have Python already. For Linux users, they've all got Python already. No one needs to come to python.org to download it. So there's no sense comparing those statistics. The one comparison that I do like, and I have the data to analyze this, I just haven't actually done it, is how quickly old versions of Python are fading from the downloads. And certainly we're still seeing downloads every month of Python 2.0, Python 2.1, which are still there, and apparently people are still clicking on them. So I'm interested in the trends of how quickly the old versions die off, which they certainly seem to be. Definitely the latest versions are the ones that are dominating, including Python 3.6 is very popular as well.
The degree to which, sort of like government contracts and other environments where really seriously legacy software is used should never be underestimated, right? These contracts take decades sometimes to age out, so it's kind of not surprising when you take that into account.
No, absolutely. Though there's certainly a number of critical infrastructure projects out there that are using very old versions of Python, which is a little bit scary, but that's the nature of the world we live in.
How does Python Tools Visual Studio compare with other Python IDEs like PyCharm?
The IDEs are a fairly similar cluster of tools. There's quite a big gap between editors and editors with plugins. There's quite a big gap between that sort of cluster of tooling and the IDEs. The IDEs, which include all of those, tend to be aiming to be the one-stop shop for once you get into the IDE, you can do everything there. There's never a need to Alt-Tab out or Alt-Tab or equivalent shortcut to change to another window. We consider that every time you have to go to a normal console to get something done, we've failed. And that's certainly the view that all the IDEs take. You should not have to open a regular console, type Python, MyScript, dash anything to make it work. If so, then the IDE has failed. So that's kind of the aim that all the IDEs have. And for the most part, we all tend to get there. So how they compare against each other tends to be in the very specific narrow cases. So there's certain areas where Visual Studio is going to be ahead of PyCharm. There's certain areas where PyCharm is definitely ahead of Visual Studio. And the other IDEs are going to be better in their little areas. Spider is one that has quite an interesting niche right now where they're doing a lot of cool data science stuff that the other IDEs simply aren't doing. And so if that's an area that you need, if that's the tooling that you need, that's going to be a good IDE for you. Visual Studio's debugging support is often cited as the reason people are using it. I think we're the only IDE out there that has mixed Python and C debugging. GDB can certainly do it. We have it in a graphical form, which lets you visually set breakpoints in the editor and say, this is my C file, I want a breakpoint here, this is my Python file, I want a breakpoint here, and I can start running, and it will stop at each of those breakpoints. I can inspect the native variables, I can inspect the Python variables, and have a really sort of mixed together view of the world there, which is something that we keep hearing, especially from a lot of big companies, that is the reason they're using Visual Studio, because they have that functionality and no one else is offering it to them. Otherwise, feature-wise, we're all largely around the same area with The little tweaks within error margins. None of the IDEs are as simple as text editor with plugins, but I don't think there's many areas where any really jump out as especially unique.
That's interesting. I was thinking that one of the things I always valued about Visual Studio, admittedly I haven't used it extensively in quite a while, is the IntelliSense syntax. To call it highlighting is damning it with faint praise. Syntax tools, basically, that allow you to do some really interesting, rich introspection things with your code. And so I was wondering if perhaps Visual Studio had anything interesting to bring to bear for Python with regards to that.
Yeah, absolutely. The latest two versions, so the most recent version of Visual Studio 2015 has the option to install our Python support when you're installing it. Earlier versions we've been a separate extension. Newer versions of Visual Studio, which there are a couple of previews out now, have Python even more front and center. It's a very easy option to select, and that brings in a lot of that really awesome editor support. So you'll get nice syntax highlighting for all of your code, which includes recognizing things like, this is a class that you've aliased or that you've passed into a function, and we know it's a class still. So we'll highlight it differently even though you did an assignment, even though you put it into a dictionary and then pulled it out later. There's a lot of clever work flowing that information through that lets us visually display how your code is working, what values go where. And that also helps when it gets to completions. So when you type a word and hit a dot after it, again, if you're at the basic text editor with plugins level, maybe you'll get some information if it's really obvious what the value is, or maybe you'll just get a list of things that you've ever typed before, which is going to be a large list and not entirely relevant. With the code analysis that we run in Visual Studio, entirely statically without executing any of your code, we can very often give you exactly the type of that variable, exactly what type of values it has in it, and show you a list. We can give you a list and say, these are all the members of these three classes that this variable could be. And optionally, here's the intersection of those members. So these are the three functions that exist on all of them. These are the only ones you should call. We can display that to you. And once you get into each of those, now we can tell you what parameters they have. Here's the doc string, and bring all that information from where it's originally written and put it right in front of you where you're currently typing.
And is it able to leverage any of the features of the typing module or tools like MyPy for being able to surface some of the information that they expose?
Currently, no. And that's simply because we haven't gotten to supporting that yet. It's certainly something that we've put a lot of thought into. It's an interesting thing to approach. So our model for figuring out all of the types predates the typing module, predates function annotations and typing annotations. So we have a model that works, and the function annotations is a little bit of a spanner in the works because it puts us in a position where we now have known information, but we also know the information that it's meant to be telling us. So if someone puts a type annotation on a function parameter and we know that that function parameter could be something else, we could, how do we deal with that? If someone says this must be an integer, we know that it's being used as a string everywhere. Who's right? Do we assume that, okay, you said integer, guess it's an integer, everyone else is wrong? Or, this is called 100 times already and it's a string every time. And now you're saying it's an integer, you're wrong. So it's something that we've put a lot of thought into and haven't yet settled on and implemented a method to take advantage of those types. I suspect when we do, it will be along the same lines of how PyCharm does it. If you specify type annotation, that is correct, and everyone else is wrong.
Yeah, just being able to surface the fact that there is a conflict would be useful, I think, regardless of what the end decision is as to which set of information should be correct, because just knowing that there's a conflict will provide enough context to the developer to know that something has to be done, and then they can at least make the decision as to which direction they want to go with it. So are there any aspects of developing Python on and or for Windows that would be compelling enough to convince users on other platforms to make the switch, whether that's platform features or tools that are available, for instance, in Visual Studio?
So yeah, Visual Studio is definitely convincing to a lot of people. There's a number of comments on Reddit and Twitter that members of my team have screenshotted and repeatedly send up our management. Things like, I reinstalled Windows just so I could use this. So we're definitely seeing some of that. I think the most compelling feature coming up at the moment for people that are looking to switch, and especially people who are currently on, say, Mac OS, because they like that there's a terminal that they're familiar with, and there's good tools and a good graphical interface, and it's going to be compatible with a lot of other devices, but it's also got that sort of basic POSIX layer is in the next update coming for Windows 10. I believe it's coming out this month. I don't actually remember the exact date. I don't know if the exact date has been announced publicly either. Is a Linux subsystem, which there's been some talk about. It was announced a little while back. There is now the ability in Windows to run a complete Linux kernel within Windows. So it's not a virtual machine. It's actually a device driver inside the kernel that is running a full Linux kernel. So you can run a complete Ubuntu session on there, or potentially any distro that you want to be working with, and not have to reboot the machine. It's not dual booting. You don't have to switch into an isolated virtual machine. It's right there. It's integrated with the Windows file systems that you have, so you can directly share files. Over time, the tooling is definitely going to get better for that. So my hope, my sort of pie in the sky dream, which as soon as I can, I'm going to do, is the ability to be working in Visual Studio, working on Python code, developing it, and then when you hit F5 to start debugging, it will run on Linux in this subsystem and be letting you debug code that's running literally on Linux without having to switch to another machine, without needing more hardware, without needing separate isolation magic, with no extra steps. It's really Linux on Windows right there, just so developers can be comfortable with the tools that they have, with the target platform that they're working on, so that packages can be installed. And yes, when you're running this Linux subsystem, you have a C compiler because GCC is there. So you can certainly install whatever packages you need on that. But that's certainly one of the most compelling things, I think, for developers that's coming out soon.
Yeah, I think that once that actually hits general release, that a lot of people are going to make the jump back to Windows because of the fact that they'll have access to everything in both platforms. The implementation I heard briefly referenced as sort of the inverse of Wine, though I don't know how accurate that is.
Yeah, so the implementation is essentially a kernel shim. So anywhere that normal Linux distro would make a syscall, that gets intercepted and translated by a device driver that's in Windows and transformed into the native syscall behavior. So it's a shim at very low level. I believe they said there's only 300 and something syscalls they needed to implement, which is a much lower number than something like Wine. Wine is implementing a layer at the user layer, so it's intercepting every single call into the operating system and redirecting that. This is a much lower level, so you get a genuine Linux, not the genuine Linux kernel, but everything above that is exactly the same. So you can install a full distro and you'll get every tool, exact behavior, complete binary compatibility, because everything is still running on the system it thinks it is. It's just once it hits the syscall layer, it's being transformed into the equivalent of a Windows system call rather than going through the syscall it would normally go through.
I'd be interested to see what desktop environments end up looking like in that context.
I'm interested as well. I don't think you can put a desktop shortcut directly into a Linux program yet, but I'm sure that's on its way.
So could you give our listeners a whirlwind tour of the underlying implementation of Python tools for Visual Studio? How does Visual Studio provide in-depth introspection for your Python code?
This is going to be quite the whirlwind. We have a 1-hour recording internally for new members of our team describing this. Let me try and give you the 30-second version. Essentially, we have an implementation of Python, which we've rewritten, that executes your code, but instead of using values, it uses types. So anywhere you have a variable that you assign a value to, we remember the type. And then we basically try and flood fill that throughout all the code that it reaches. So anywhere there's a function call, passing that as a parameter, we'll flow the type through, and just try and keep flowing it through until we hit the boundary of where nothing else passes that variable on, and say, okay, now we know what the types are up to here. That is actually a ridiculously huge problem. As I'm sure you can imagine, normal code has loops. A lot of normal code has infinite loops, and there's conditions there that that would break out of that we simply can't assume that we can't understand when we're only dealing with the types. So there's a lot of the magic is knowing when to stop, and typically we do have to stop early. So typically you won't get 100% perfect information, because to do so would take forever, and you'd definitely run out of memory. You'd probably run out of, the sun before it's 100% complete. But we do have the heuristics are, I guess, the secret sauce for when is this information good enough that we can stop trying to evaluate it from here. But essentially we simulate executing the code, and instead of passing around the values, we just pass around the types and end up with a model of the code where each variable has its set of types associated with it. As for the rest of Visual Studio, so Visual Studio is this amazing platform. It's very much like an operating system. It provides this huge set of services, a whole lot of generic user interfaces. Everything is very extensible. There's one team that we call the platform team that does the core piece, and every other part of Visual Studio, every other language, every other extension, basically every feature, up to and including the text editor, is an extension on top of this core base. So it's a hugely extensible platform, which makes it really fun to develop for in a lot of ways, because if you see that someone has done something, so if you see that someone has made the editor do something clever, there's a way for you to do it as well. If you see that someone has added a window with certain functionality, there is also a way for you to do that. There's nothing that Visual Studio does that can't be reproduced by someone else, that you can't reproduce in your own extension, which is really cool. Though it's not necessarily easy, because unlike most operating systems, it's frankly not as well documented, and it's not anywhere near as stable as an operating system would be. So there's challenges either way, but it's definitely a platform to develop on top of. It's very amenable to that. There is plenty of good documentation, examples, and for us working internally, we get to look at some of the internal examples, and then when we take our code and make it open source, that helps other people come and see, how did they do this? Oh, now I can reproduce this in my own code, which is everything from supporting project systems, extending the debugger, extending the profiler, extending publishing support if you want to publish code to another machine or to the cloud. All the IntelliSense tricks that we do, all the completions, tooltips, it's all extensible, and the fact that our code gets to be an example of that to the rest of the world is really cool.
Absolutely. I guess one thing that I was wondering about when you were discussing previously these sort of internals of PTVS with the typed version of the person's code, where is the line in that implementation between the C# and the Python?
So the original implementation of that was in Python. That got translated to C#. In large part, I believe it was because of the way garbage collection works. Python's garbage collection was not efficient enough for the amount of sort of dangling references we were dealing with. This predates my time on the project, so it's always been written in C# as far as I'm aware. Now that I'm controlling the direction a bit more strongly, I'm trying to move what makes sense into Python code and sort of minimize adding new C# code, in large part because I want to encourage contributors. And when we can say 90% of the debugger is implemented in Python code, if you found a bug, you can probably fix it, and then you can send a pull request, which we're allowed to accept, then that's really cool. But certainly the code analysis is largely C# for performance. So there's sections there that are deliberately marked as unsafe so that they'll execute quicker. There's parts that rely heavily on tag and sweep garbage collection rather than cycle detection. Simply because there are thousands and thousands of cycles all the time. And if it was written in Python, the cycle detector would spend all its time trying to detect them and probably not even be able to break up many of them. So yeah, we went to C# for that.
So are there any questions that we didn't ask that you think we should have, or any other topics that you'd like to bring up before we start to close out the show?
No, I think that's fine.
So for anybody who wants to follow you and keep up to date with what you're doing, what would be the best way for them to do that?
Probably the best way is to follow me on Twitter. So my name there is Zooba, Zooba. Don't ask how I came by that name. I was 13. I keyboard mashed, and it's stuck around ever since then. And so everything that my team does goes up on GitHub. So github.com/Microsoft. You'll find the organization, and if you search for Python in that, then you'll find a lot of my team's work. There's also github.com/Azure. And again, if you type Python, you'll find a lot of that. And typically I go by my real name everywhere else. So Steve.Dower is going to be me on the Python bug tracker and forums like that.
Great. So with that, we'll move us on into the picks. I've got 2 picks this week. My first one is a tool called kdiff3. That's what I use as my merge tool when I'm dealing with Git conflicts. And it's the best one that I've come across so far. I've tried a few different ones, but for visual merge tools, it does a really good job of throughway merges. It exposes easy ways to set the key bindings that you want. I'm a user of Emacs for a few years now, so my fingers always want to use Emacs key bindings, so I set it to use Control-N and Control-P to jump to the next and previous diffs, and it's easier to automate than some of the other ones I've tried to use. And my next pick is something called the Spyderco Triangle Sharp Maker. It's a sharpener for knives and scissors and basically anything that you have that has an edge, you can use this to sharpen it. And it just does a really good job. It makes it easy to add an edge to your kitchen knives or a pocket knife. It even handles serrations, does scissors. So definitely recommend taking a look at that for your kitchen or anywhere else that you have need of bladed instruments. And with that, I'll pass it to you, Chris.
Thanks, Tobias. My one pick today is audiobooks. Specifically, I'll use Audible because that's the vendor that I'm using. I love reading fiction in actual print form, but I, for some reason, have realized that nonfiction, trying to read it in print form puts me to sleep, but audiobooks I can cruise through with no problem at all. So I'm really enjoying that. That's all I have for picks this week. Steve, what do you have for us for picks?
Yeah, so I went ahead and picked a couple. The first is going to sound like a product placement, and it's not because no one's paying me for this. I picked up the SanDisk Extreme portable SSD hard drive a while back and almost immediately went back and got another one. This thing is like 500 gigabytes, SSD, USB 3, so I get over 100 megasecond transfer. And the thing is a quarter the size of my phone. It's like I put it in my pocket and I can forget that it's in there. So that is really cool. If like me, you end up transferring huge amounts of files around physically rather than sending them all up on the cloud and downloading them elsewhere, that's really great. SanDisk has not paid me for that. If you want to send me more of the hard drives, don't bother, I have enough. But that's a really cool hard drive. My other 2 picks are both kind of light entertainment. Most of the time, once I get out of work and just want to hop on the internet, it's sort of relaxing time and just light entertainment. So Saturday Morning Breakfast Cereal is a webcomic that I've been reading for years. This stuff is hilarious. So the website is smbc-comics.com. The guy who writes it, Zach Weinersmith, is very smart, man, knows a lot of stuff, and is able to turn it all into really often intelligent jokes, occasionally butt jokes, but often intelligent jokes, to do everything from philosophy, technology, computer science, physics. It's very entertaining. Always get a good laugh out of it. And my last pick is my favorite YouTube channel right now, which is called Random Encounters. The channel name is youtube.com/randomencountersent for entertainment, ENT. And these guys make gaming musicals. So they aim to make a musical each month about a video game or based in a video game. They tend to be short, so it's like one song out of a musical. But they've got some really great ones based on Pokemon, really great Zelda ones, Team Fortress 2, Five Nights at Freddy is a recent game that they finished doing a short series of musicals on. Very entertaining stuff, very well performed. A lot of cool people from around the YouTube coming on and singing and performing with them. It's great light entertainment. I really enjoy it.
Well, thank you very much for taking the time out of your day to join us and tell us all more about Python on Windows and some of the different tooling around that. Definitely excited to see what happens once the Linux subsystem becomes generally available. I'm sure I'll probably end up experimenting with it a bit. I appreciate all the work you've done to simplify installation of Python. It's made it easier for me to get it up and running to work on it with my kids.
Great. Thanks for having me on.
Thank you. Bye-bye.